In this investigation, we are measuring the effects of changes in temperature and enzyme concentration on reaction rates of an enzyme-catalyzed reaction. So this will be a controlled experiment where we're going to try to explain how environmental factors affect the rate of enzyme-catalyzed reactions. For part A of this experiment, we'll start by putting 2 milliliters of 3% hydrogen peroxide solution into the clean test tube. So I have my hydrogen peroxide solution here, my graduated cylinder, and we'll start by measuring out 2 milliliters. Oops. All right, we've got 2 milliliters measured out, and we'll add it to our test tube. We will then add a small piece of liver. And we are using chicken liver in this particular experiment. I'll push it in so it gets all the way down into the hydrogen peroxide. So you can see that there is some bubbles or a gas being released. Also, remember, some reactions are endothermic, whereas others are exothermic. So if I feel this test tube with my hand, you can feel a temperature change. I'll let you observe the bubbles here. Now we're using a 0 to 5 scale for this experiment. If we say 0, that means no reaction is taking place. If we say 5, it's occurring very, very fast. We're going to use this as our baseline and make the assumption that this particular reaction is taking place at a rate of about 4. So it's not super duper fast, but it's also not very slow. Now I'm going to pour off that liquid solution from the first test tube directly into the second test tube. I'm keeping the liver still in the original test tube and setting that off to the side. So take another piece of liver, add it into my test tube. See what happens. Is any reaction taking place? So you can see on the very bottom, there's some bubbles starting to form. I'm going to go back to our first test tube and add an additional 2 milliliters of hydrogen peroxide. Is it still having a fast reaction in that first one? So is catalase reusable? So is that first piece of liver able to continue doing that same reaction over and over again. You can see the liquid from the first test tube when poured into the second. We're not seeing very many bubbles coming out, so that reaction has driven to near completion at this point. But with fresh liquid, a piece of liver that's been used before can be used again and continue that reaction. All right. For part B of this experiment, we're going to look at what tissues contain the enzyme catalase. So I'll remove these test tubes and set up some new ones. All right, so our potato goes into the test tube on the far left. Our apple goes into the test tube in the middle. And then we'll have another little piece of liver in the test tube on the far right. There it goes. All right, so we need, again, about 2 milliliters of hydrogen peroxide in each of the test tubes. Add it to our potato first. Make observations of what is happening. Then we have our apple in the middle. And then again, our liver on the far right. Let's make observations of the relative rate of reactions. So potato is on the far left, apple is in the middle, and chicken is on the far right. Remember, catalase is the enzyme that is causing this reaction to take place. If a particular tissue has more catalase in it, it will be able to do the reaction much, much faster. And if I zoom out just a little bit, you can see just how much those bubbles are growing or expanding in the liver test tube. For the final section of this experiment, so for part C, we are going to look at the effect of temperature on catalase activity. So we'll start with 4 test tubes, and we'll put a little bit of liver in each of the test tubes. So we'll start with the first test tube, put liver in the bottom, cover it with a small amount of water, and then we're going to put this particular test tube in the boiling water bath for 5 minutes. So add a little bit of water. And then using our test tube clamps, we will transfer this over to the hot water bath. So we're going to let it sit in that hot water bath for about 5 minutes. Now that 5 minutes has elapsed, we will remove our test tube from the hot water bath using our clamps and place it back in the test tube holder. We'll now pour the water out of the test tube and then add 2 milliliters of hydrogen peroxide. So I'm removing the water from the test tube, leaving the liver inside. And then I will add in 2 milliliters of hydrogen peroxide. We will observe what takes place when this is added. So I'll zoom in first. So we're looking for the rate of reaction in this test tube on the far right. And we're observing that there are not any bubbles forming. So that means the reaction's not taking place. So our reaction rate for the boiled liver with the hydrogen peroxide added is essentially at 0. There really is not any reaction taking place. For the next part of this, of part C, we will put equal quantities of liver into 2 clean test tubes and 1 milliliter of hydrogen peroxide into 2 other test tubes. So I'll rotate a little bit. So we have 2 test tubes with liver and 2 empty test tubes. I'll add 1 milliliter of hydrogen peroxide to each. We'll then put 1 test tube with liver and 1 test tube with H2O2 into an ice bath. So I have a beaker with ice water, and we'll also put another one into a warm water bath. So we have a beaker with pretty warm water. Move this to the side. You can see on the thermometer that the temperature of the water is right around 36 to 37 degrees Celsius in the warm water bath. In the cold water bath, it is much, much lower. It is right around, oh, it's still going down. Still going down. It's right around 10 degrees Celsius, a little bit below that. So we have a test tube of hydrogen peroxide and a test tube of liver in each of these water baths. Now the warm water bath, that is not hot. It is just warm water, a little bit above room temperature. And we'll let them sit in these water baths for about 3 minutes. So again, always use your test tube clamp when handling test tubes out of warm, cold, or hot substances. So we have our liver from the cold water bath. I'll slide this back so we can see it. Take our hydrogen peroxide from the cold water bath and carefully pour it into the liver test tube. And we can see a reaction beginning to happen. We'll do the same thing with the warm water bath. And then carefully add our warm hydrogen peroxide to that test tube. And again, you can see the reaction happening. Now, is that reaction happening faster or slower in that warm water bath versus the cold water bath? Make some good observations.